Hi guys, and welcome back. Today we're going to have a look at calculating capacitors in series. You can see I already have taken the privilege of drawing the circuit as well as calculating the circuit, just in the sake of not wasting any time and not making the video that long. Before we go into the calculation, I just want to explain the pyramid here. From this pyramid you can derive your formulas, right? You can calculate your charge, which is equals to my capacitance times my voltage. You can calculate your voltage, which is my charge divided by my capacitance, and my capacitance is equals to my charge divided by my voltage. You can also calculate a charge if the values of the capacitance and the voltage is unknown. So if, however, they give you the current and the time in the circuit, you can calculate the charge using that specific formula. Right, so let's go into the circuit. Here I have a capacitor C1, which is 7 microfarad, C2, which is 5 microfarad, and then I'm going to calculate the voltage drops V1 and V2 over that capacitors as well. My total voltage or my supply voltage is 12 volt. Right. So the first thing that you need to do is you need to calculate the total capacitance of the circuit. Now here I have two formulas. You can use any one you choose, the one that suits you best. Let's see how this is being done. So I'm going to write 1 over CT is equals to 1 over C1 plus 1 over C2. Then I'm going to put in my values, 1 over 7 plus 1 over 5. Then the next thing I need to do is I need to choose a value which 7 will go in and which 5 will divide in as well without anything left. Alright, so that will be 35, and I can say that 35 divided by 7 will give me 5. 35 divided by 5 will give me 7, so that in total will be 12 over 35, and which means 1 over CT is equals to 12 over 35. Now, that is not what I want. I want CT, which means I need to turn around here and I need to turn around here. What I do here, this side, I must do that side as well. That's simple mathematics. Alright, so my answer then is 2.917 microfarad. That will be my total capacitance. The same on this side with this other formula. It's a little bit easier in the sense of when you're having two capacitors in series, is basically whereby you say C1 multiplied by C2 is divided by C1 plus C2, which will give me 35 divided by 12, and that will also give me 2.971. Next, we're going to calculate the total charge in the circuit. And my total charge in a series circuit is equals to my total capacitance times my total voltage. And in this case, it's going to give me 35 microcoulomb. I just want to go back to this part here. Sometimes you will see that if you press these values into the calculator, you will either get 10 to the power minus 5 or 10 to the power minus 4. You need to convert that to 10 to the power minus 6 on your calculator. Or you can just say, if I shift the comma one side once that way, then I must also change the power of my which I have there. Alright, and that will give me 35 microcoulomb. The next thing that we will be calculating is calculating my voltage drop over capacitor 1 and my voltage drop over capacitor 2. Now here you will see I'm using the total charge in my formula. The reason why I'm using the total charge in my formula is because when we're working with a series circuit, it means that my total charge is equals to the charge in capacitor 1 as well as for capacitor 2. So which means my charge in a series circuit stays the same. Alright, so let's go back to the voltage drop. That will be my charge divided by my capacitance for my capacitor, which will give me 5 volt for the voltage drop of V1. V2, it will be my charge divided by my capacitance for C2, and I will get 7 volts. What I also want you to see here is the fact that the sum of my two voltage drops must give me my total voltage in the circuit. Alright, here in this block I have just proven that, in fact, that Q1 and Q2 is equals to the total charge of the circuit. Alright, the next thing that we will be calculating is we will be calculating the energies. I'm just shifting up the page a little bit so that we can see. Alright, so here I have three formulas, which is the same actually. The only difference is the first one I'm calculating the actual energy of the whole circuit, and the other two I'm calculating the energy in capacitor 1 and capacitor 2. Alright, so let's go ahead and see how this has been done. And that is going to be half times my capacitance, my total capacitance of the circuit, multiplied by my voltage squared. And that is going to be 0.21 millijoules. I'm just going to write here squared. That will be squared, and that will be squared. So that is for my total energy in my circuit. The next ones, I'm calculating the energy in the specific capacitor. What is the energy in capacitor C1 and capacitor C2? Which means it's going to be half. For C1, it's half times my my capacitance times my voltage squared, and that's going to give me 0.0875 millijoules. And lastly, the last one is half times my capacitance of C2 multiplied by my voltage squared, which will give me 0.1225 millijoules. And if you add these two together, you will see that you will get what the total energy of the circuit again, which means you have calculated correctly. And guys, that is how you calculate a capacitors in series. Thank you very much.